Good morning. My name is Dr. Johnny Stitts, and I have been in education for 12 years now. This is my 12th year. I am a non traditional teacher, but I do have a mathematical background. I got my bachelor's in mathematics, my master's in mathematics, and then I went on to get my doctorate in organizational leadership with an emphasis in math education. My current teaching certifications, I am 712 certified, and I've been in the classroom. I was in the classroom for 10 years, but now I've spent the last 3 years serving as the secondary mathematics specialist for my district. All right, guys, so we are going to continue our discussion of the Pythagorean theorem. If you recall, when we left off, we were focused on the proof, okay? And we spent a lot of time showing in many different ways that the two legs squared is going to be equal to the hypotenuse squared. So we looked at a model using water, and we looked at some squares, which we're going to revisit here in just a second, okay? But so for this first example, what we want to do is construct a logical argument to show that a squared plus b squared equals c squared. Okay, so who would like to walk us through this example? How did we model this the last time? That's exactly right, right? So we took the squares from the legs. So here you can see we had 16 squares on one side. And we had 9 squares on the other. Exactly. And we took these and we put them over here, right? So the 9 squares plus the 16 squares gave us the 25 squares. So that's how we proved that a squared plus b squared equals c squared. Okay, so let's put this into action. I need a volunteer to read this example for me. Go ahead, Mark. Thank you. Okay, so Mark, you've read the example. I really appreciate you. Thank you for sharing with us. Can anyone tell me what is going to represent the hypotenuse in this example? That's right. It's going to be 25. And how do we know it's 25? Exactly, because it's the longest side, okay? And what about the 15 and the 20? Okay, so 15 is going to be A and 20 is going to be B, okay? Now, did it matter which was which? Could 15 have been B and 20 have been A? Exactly. Okay, so we know that it doesn't matter which leg is which. As long as we ensure that the hypotenuse is the longest side of the triangle, everything is going to be okay. So here we get 225, and we get 400, and we get 625. So for the sake of this example, we weren't really solving anything. We were just proving the Pythagorean theorem, right? We were just showing that a squared plus b squared equals c squared. But we could continue if we needed to. We could add these two numbers together, and we see that 625 is equal to 625. All right, so for this next example, right, this is a pretty direct problem, and you can see that we have to find the length of the hypotenuse of the right triangle using the Pythagorean theorem, okay? So I'm going to need some help from you guys, right? Someone start me out. Beth, what is the Pythagorean theorem? What does it state? Very good. A squared plus b squared equals c squared. Okay, awesome, awesome. All right, now, Addie, what do A and B represent? Correct. These are going to be my legs, okay? So a leg squared plus a leg squared is going to equal the hypotenuse. And I'll use HYP for short, squared. Okay? And Liam, what should my legs be? Okay? Okay, so 8 squared plus 15 squared equals c squared. All right, so why did you use c? Because that's an unknown. Very good, very good. Okay, so help me out. 64 plus 225 is equal to c squared. Okay, what do we get when we add those up? Very good. 289 equals c squared. Okay, so kind of running out of room. Let me move this around a little bit. All right, and so we're going to take the square root of 289. That's going to equal c. And so we get 17 equals c. Okay. Now let's explore that a little bit. We know we got 17, right? But we also talked about when we take the square root of a number, we get two solutions. We get the number that the calculator, if you're using a calculator, generates, but we also know we get its opposite, okay? So why do we not use 17 and negative 17, Mark? That's right, because negative 17 here is not applicable because you cannot have a negative length. So we're just going to omit that solution, okay? All right, and we have one more example here that we're going to look at today before we get to work on our practice and problem solving. And I need a volunteer to read this problem for me. Thank you, Addie. Go ahead. Very good, very good. I really appreciate you reading that for us. Okay, now I do think this problem's a little tricky because as you can see, they give us an image. We're looking for B, but the question, as Addie just stated, is here. So I'm going to highlight that for us, is does Maria have enough to repair the display case? And she has a piece of trim that is 20 inches long. Okay, now I'm really emphasizing this because last year I had students that tried to plug in 20, right, as B, and they were like, well, 20 squared plus 20 squared equals 29 squared, okay? But I don't want you to take that approach. It's an okay approach. You can see if it satisfies the equation, but what I want you to do is figure out what B is, right? Not if 20 works or not. What is B? And then make your inference from there, okay? So we know that A squared plus B squared equals C squared. And in this case, we're given A, which is 20. We don't know B, and we know C, which is 29. Okay, so it's a little different, right? It's not direct. We can't just add and take the square root. We're going to have to do some manipulations to solve for B, okay? So let's simplify this first. So we have 400 plus B squared equals 841. All right, now, Mark, how do I go about solving for B? How do I get B by itself? Okay, now do I just finish that for me? I'm not just going to subtract 400. Very good, very good. I'm going to subtract 400 from each side of my equation. Thank you, Mark, for your precision. So I have b squared equals 441. And now I'm going to take the square root. And what do we get here? That's right. So b equals 21. Okay? Now, we know that b is equal to 21, but we also know that Mara only had 20 inches. So the question is, does she have enough trim? What do you think, Addie? That's right. The answer is no, right? She is 1 inch short. Very good, guys. Okay, so that's our lesson today. Those are the examples that we wanted to go over. And so now we'll spend some time practicing problem solving. And if you need any help whatsoever, you make sure to let me know, okay? Thank you.